So finally we move to the EOT for 11 Advanced Physics Term 3. Similar to like other classes, you have 4 questions which are going to be there in the writing, that is 40 marks. So basically 4 questions of 10 marks each. And there are 15 questions which you have in the MCQ, 4 marks each, which is 60, and in total that's 100. So basically we will be starting with the writing part first, and then eventually we'll move to the multiple choice questions, because writing part you would be able to cover most of the curriculum, and then MCQs would become relatively easier. So the first concept is determine the locations of the center of mass of 2 or several particles. Okay, about the center of mass. So as we have discussed in the class, a center of mass is an imaginary point or a point which resides along the body or in the body itself, where the entire mass of the system can be concentrated. Now, what is the basic methodology to get the center of mass? So let's say I have 2 masses. It can be again any number of masses, m1 and m2, and they are separated by some distance. Let's assume the distance to be d. Now, what we are doing is that the first step is to imagine a coordinate axis if it is not given to you. But if it is given already, then you can use that coordinate axis. If it is not given, make a coordinate axis. So let's say this is the coordinate axis, this is x, this is y. Now what you have to do, you have to write the coordinate of every mass which is present there. So here it will be 0, 0, and here it will be d, 0, because at a distance d away. Now if you need to find out x coordinate of the center of mass, it's basically m1 x1 plus m2 x2 over m1 plus m2. Now remember, this can be n number of masses. That is why this result is sometimes represented as sigma mi xi over sigma mi, running from 1 to n. It can be any number of masses, but you cannot put it in the calculator to get the result like this. You would have to put the values individually, because the masses are different and the locations of the masses are also different. This will give me the x coordinate of the center of mass. Similarly, I can find the y coordinate of the center of mass. And once I have both x and y, I can locate that wherever the center of mass is going to be. We have discussed this multiple times in the class as well, that logically the center of mass resides closer to the heavier mass. So let's go through the question if there is any. Here, 3 identical balls of mass m are placed in the configuration shown in the figure. Find the location of the center of mass. Okay, they have given you the coordinates as well, 0, 0, a 0, 0, a. You have to find out the center of mass. So if I need to find out x center of mass, xcm, what will I do? 3 identical balls. So the masses are m, m, m. If you have issues solving the problem with variables like m, x, n, if they are identical, you can take them 1 kilos each or 2 kilos each or whatever you want to, any number. So m1 x1, so let's take this as 1, this as 2, this as 3. You can take any of them as 1, 2, 3, it does not matter. So m times 0 plus m times 0 plus m times a over m1 plus m2 plus m3. So eventually it becomes ma over 3m. M cancels, I will get a by 3. Same way, when you will calculate ycm, you will take the y coordinates and you will see the result will come out to be as same, a by 3. So where is the center of mass? A by 3. This is a by 3 would be 1/3 somewhere here, and a by 3 here would be 1/3 somewhere here. This would be the point of the center of mass. This is the location of the center of mass. This is what you needed to calculate. You can also represent it vectorially as it is done in your book there. It's basically a by 3 x cap plus a by 3 y cap. This is the center of mass, or a by 3 comma a by 3. These are the 2 ways in which the center of mass could be represented. Next. The system is kind of slow. Okay. The coordinates of the center of mass for the extended object shown in the figure are L by 4, minus L by 4, 5. So they have given you the x coordinate and they have given you the y coordinate of the center of mass. So this is x cm, this is y cm. What are the coordinates of the 2 kilo mass? I need to find out x, y. It's simple. You have the coordinates of these. Now, most of you find the values of unknowns by solving for x, shift solve. But the issue with that is you cannot put L and Y's because you can just put one variable there. So I would recommend that if the coordinates are given in the form of A, L, B, just assume it to be anything, like just assume L to be equal to 1 and solve everything according to that, and then whenever the final value comes, if there is 1 in that, change it to L. That's how you can basically move. Okay, so let's start. Basically what we have to do is xcm is equals to m1x1 plus m2x2 over m1 plus m3x3 over m1 plus m2 plus m3. You have the values. Take this as 1, take this as 2, take this as 3. xcm is L by 4. m1, the mass is 2 kilos, so 2x plus m2, the mass is 3 times L plus 3 times 0, the mass is 4 times 0 over 2 plus 3 plus 4. What do I get? 2x plus 3L over 9 is equals to L by 4. Now, the problem with this is that in the calculator you cannot have like two unknowns here. But here you need to understand that L is not an unknown. L is a number. It can be anything. So if you know how to solve this, it is very easy. All you have to do is cross multiply. 9L is equals to 4 times 2, 8x, 4 times 3, 12L. This, if I take this the other side and bring this the other side, so I will get negative 8x is equals to 3L. What did I do? I took 9L the other side, so 12L minus 9L, which is 3L, negative 8x. So x comes out to be, I have to find x, yes, x is the unknown, minus 3 by 8L. This is the value of x. You have to just rearrange the equation to find the value. And if you are not able to do that, then assume L to be equal to 1 and then get the result. Whatever the result comes, let's say the result comes minus 3 by 8, and then put the value of L because you had assumed that L was equal to 1. So that's how you can basically change it. 3L by 8. Why am I getting negative? 9L for 8x plus 12L. 12L minus 9L is minus 3, like 3L. 8x comes this side, minus 8x. X is equals to minus 3 by 8x. Yes, it's correct. Okay. They have already taken x as minus x. You don't have to do it, remember, because when we are writing the coordinate, we'll write it with plus and minus. So your result will be minus 3 by 8L and not 3L by 8. Because they have already included the negative before, that is why the result is coming as 3L by 8. Similarly, you can solve for y and you will get the result of the center of mass. If you don't know how to rearrange equations, basically, if I have a by b is equals to c by d, all I have to do is cross multiply. That's the first step. So AD is equals to BC. That's 1. Now if I need to find A, and here it is times, this is times. So I will divide both sides with D. If I divide both sides with D, I will get A is equals to B times C over D. And you're advanced kids, I'm sure you must be knowing all this, like rearranging of equations and all that. Anyway, moving to the next question. Next question, the Cartesian coordinate of point P are 3, 4 in the units of centimeter. What are the polar coordinates of the point? You have already studied this in maths as well, and we have discussed it in the class. So when we say polar coordinate, if I have a point x, y, Cartesian coordinate, Cartesian as in this distance is x and this distance is y. This x, this is y. If I need to find out the polar coordinate of that point, polar coordinates are r comma theta. So how much distance it is from the center and how much angle it is tracing, that is what we call as polar coordinate system. So if I have to find out r, or basically x, I can say that x is nothing but r cos theta, because if I take the cos theta, sin theta and all that, and y will come out to be r sin theta. So I have to convert 3, 4 into Cartesian coordinate system. That means I have to convert it into r, theta. So first take the point like 3, 4 location and find out the value of r. X is equals to r cos theta comes out to be x by r. So similarly from here you will get theta is equals to cos inverse x by r. Put the value. Not necessarily you have to take x, you could have taken y also. It would have given you the same result. Now this is theta and r is the distance from this point to this point. You can use the equation to find r, or you can use simple mathematics with Pythagoras, that is root over x square plus y square. You will get the result. Y is equals to, okay, they've calculated r using the equation. You can also do it with root over x square plus y square. Okay, it's a different question. I'm so sorry. This is the question. Yeah, same thing. So r is equals to root x square plus y square, 5 centimeter, and theta comes out to be, either you can use tan, you can use cos, you can use sine, that's completely up to you. Like here you can say that x over r is equals to cos theta, theta comes out to be cos inverse x over r. You have the r, you have the value of x, you can put the value, you will get the result. Or you can use simply tan theta is equals to y over x, theta comes out to be tan inverse y over x. I'm sure the second question is also same. A circle of radius r is equals to 8 cm, point on the circle with x component is equals to 4 cm. A circle of radius r is equals to 8 cm, a point on the circle with x component is equals to 4 cm. Okay, this is the point. What do we have to do? What is the angle theta? Simple question. This is 8, this is 4. This is 4, right? Yeah, this is 4. I need to find out theta. If I have adjacent and hypotenuse, what do I use? Cos. So that is why they have used the cosine. Because cosine theta is equals to 4 over 8 and theta comes out to be cos inverse 4 over 8. You can solve it, whatever the value comes. What is the y component of that point? So if I know this theta, I can simply say tan theta is equals to y over x. So y over 4. I have theta, I can calculate the value of y. Or I could have used sine also. Sine theta is equals to y over 8. I have theta, I can find the value of y. So it's simple, it's not that difficult. It might look complicated, slow it down, watch it one by one. By mistake, I started solving it, like I started correlating it with here. But again, it's a similar question, similar concept. All you have to remember is the components x and y, adjacent, opposite, and hypotenuse. Okay, next is the degrees and the radian measurement. What do we call basically as 1 radian? When we use the term 1 radian, what do we mean? That if this is the radius of a circle, then if I travel along the circle the same length as that of the radius, whatever length is here, if I travel the same length here, let's say this length is s, then whatever the angle would be there at the center, that angle is called 1 radian. This angle is called 1 radian. 1 radian. It's generally represented with c, you don't have to represent it. Anyway, so what exactly radian is? The angle which is being traced when my radius and my arc length are equal to each other. If I increase my radius, then my arc length will also increase, but the angle will still remain same. This is what we basically call as radian. It is easier to represent radians in terms of pi's. Like that is why we say 180 degrees we define as pi radian. Because when we calculate it, this comes out to be close to 57 degrees. Like when we find out the value. So we define, or we came up to the value that 180 degrees comes out to be equal to pi radian. Now using this, I can define all the angles. 360 degrees becomes 2 pi radians. Don't have to write radians every time. So if I know some of the angles in radian measurement, it becomes easier for me to understand or to grasp the situation. For example, a circle can be divided into, here you can see that 1, 2, 3, basically 12 parts. What are we doing? If I am dividing a circle which is 360 degree to 12 parts, every part is 30 degrees, like 30 degrees, and 360 degrees is 2 pi, so I can simply say 2 pi by 12, or every part is basically pi by 6. So this is 1 pi by 6, this is 2 times of pi by 6, this is 3 times of pi by 6, 4 times of pi by 6, 5 times of pi by 6, and basically I have to keep multiplying it, and eventually I will get to the result 12 pi by 6, and I can keep moving. And remember, anti-clockwise directions are taken as positive, clockwise directions are taken as negative, conventionally. Now, convert the degree of the angle to radian measurement. 60 degrees. How many times pi by 3? So 2. So 2 pi by 3. That's the answer. That's one way of analyzing it. Another way is you can use the formula always, that if you have to change degree to radians, what you basically do, you multiply it with pi by 180. Okay, and if you have to change the reverse, then you do 180 by pi. These are the expressions which are already given. 240 degrees. How many times I am doing it? So if you divide it with 30, you will basically get 8. So it is 8 pi by 3. Pi by 6, not pi by 3. Or 4 pi by 3. Because 30 degrees is pi by 6. Convert the radian measured to the degree. 2 pi by 3, 120 degrees. Why am I able to do it fast enough? Because I actually have understood that pi by 3 is 60, and if you are doing it 2 times, it is 120 degrees. 11 pi by 6. So 12 pi by 6 is 360 degrees. I am just giving you a logical answer. You can always solve it with formula. 12 pi by 6 is 360 degrees. It is 11 pi by 6. So that means 30 degrees less. So that comes out to be 330 degrees. Okay, this is how you convert degree and radian to each other. Determine the change in the angular position in radians. Winter lasts roughly a fourth of a year. There are 2 pi radians in a circle. Consider the orbit of Earth to be circular. I have to find this. This is 90 degrees. That's pi by 2. Or I can say that 3 times of pi by 6, which is pi by 2. Yeah, pi by 2. Generally, we leave the answers in pi, but sometimes they would change pi as 3.14 or 22 by 7. That's also alright. So here they have done is change pi to 3.14 divided by 2, we get 1.57 radians. It's a simple question. A person on a Ferris wheel with diameter of 12 meter has an angular displacement of pi radian. Okay. When I say angular displacement, it means how much angle it has subtended, how much angle it has cut out. Diameter of 12 meter. So this is the diameter, 12 meter. Has an angular displacement of pi radian. That means the guy comes from, or the person basically comes from here to all the way here, because this is pi radian. 180 degrees. How far has the person traveled around the circular path of the Ferris wheel? If you use your brain, it is half of the semicircle, which is pi r. Pi is pi, r is 6, so 6 pi, or 6 times 3.14. Do we have a result? 16.84 meters. If you want to use the formula, you can also use the formula. Theta is equals to S. This is called arc length. This is theta. This is r. So theta is equals to S over r. This they want. Radius I have, which is half of the diameter. Remember, don't forget, theta is given. Remember, this theta must be in radians. It can't be in degrees. Only then you will get the result. Next, a boy swims for 20 meters around the edge of a circular pool of 5 meter radius. What is the boy's angular displacement? Around the edge of a circular pool. 20 meters around the edge of a circular pool, 5 meter radius. This is a circular pool. Always try to imagine the picture, because that makes it very easy. 5 meter radius, and he travels a distance of 20 meters along the edge. So Let's say this is 20 meters. We don't know. What is the boy's angular displacement? That means they want the angle here. So what should be the angle here? Theta is equals to S by R, which is 20 over 5 or comes out to be 4 radians. This is theta, 4 radians. What do we understand by 4 radians? If we focus a little bit, 4 radians is more than the semicircle. Because 1 radian is close to like 57 degrees or something. So if we talk about pi radian, when we say pi radian, okay, pi radians is 3.14 radian. It is slightly more than 3.14. That means 4 radians. So the person has actually traveled. If the person has started from here, he's gone all the way here. That is half the circle and a little bit more. So this much distance has been covered. Okay. Always try to analyze the question and understand, like analyze the answer as well, that what you are getting. What is the physical significance of that? Next is also a similar question. A car on a circular track moved from point 60 to 67 pi by 6. 7 pi by 6 means it has travelled pi by 6 7 times. So after 180 degrees, again 30 degrees, 210 degrees. The units for the radius are in meters. How far did the car move? Simple question, you can solve it always. This is the angle, this is the path length you have to cover or calculate. Question 17. Before getting to question number 17, I'll just clear up some concepts here a little bit. When we say linear speed, or we are talking about rectilinear motion, and when we take angular speed or angular terms, there is a correlation. What is the correlation? Try to understand. If this is the pen which is rotating like this, then if this was the pen and which is rotating, you would always notice that this part of the pen, this part of the pen, this part of the pen, and this part of the pen, they are traveling different distances. They are traveling different distances, but they are all reaching here at the same point. So when they are reaching at the same point, sorry, not the same point, in the same time at different points, and they are traveling different distances, therefore time is same, distance is different, so therefore speeds will be different. But that will be the linear speeds. That will be the linear speeds. This will be faster because it has traveled the maximum distance. In the same time, this has traveled less distance, so slower, very less distance, very slow, relatively slow. This one hasn't traveled at all, it has just rotated, moved the point. So basically this is fast, linearly, remember. But all of them are tracing equal angle. The angle traced by them is same. So angular speed is same for all of them, but linear speed is different. And the relation between this angular and linear speed is given by, angular speed is represented by omega, as you already know. Linear speed is v. So the relation between them is given by v is equals to r omega. R times of omega, where r is the, not the radius, remember, r is the distance from the center to the point about which we are talking. For example, if I am talking about this point, this is r. If I am talking about this point, this is r. Like that. Whatever circle it is cutting. Now, here an important point. If two objects are rotated like this, so if they are continuously touching, this one is moving here, this one is moving here, then their linear speeds at this point is same. They both are traveling at the same speed. But this is rotating, or the angular speeds for both of them are different, because by movement of this much it might trace this big an angle, but by movement of this much this will trace a very small angle in the middle. So the angular speeds might be different for both of them, but the linear speeds are same when they are like attached to each other or they are moving to each other. Similar to speed and angular speed, we have acceleration. Acceleration is change in speed, which is a. When we talk about angular acceleration, that's alpha. We have discussed this in class multiple times. The relation between these two again goes same way as like v is equals to r omega. So a is equals to r alpha. Alpha is radian per second square. Omega is radian per second. Velocity is velocity, as in like meter per second. Acceleration is meter per second square. One more thing, you will get something called RPM. Rotations or revolutions or repetitions per minute. Every minute, how many times it's rotating. So if I have RPM, that means in one rotation the angle being traced is 2 pi, 360 degrees. So that means 2 pi if something is moving at 30 RPM. 30 RPM. So it is doing 30 rotations per minute. That means 30 times 2 pi angle is being traced every 60 seconds. So this is the angular speed of 30 RPM. So if you have to change from RPM to radian per second, it is 2 pi over 60. You have to multiply it with 2 pi over 60. That is what will give me radian per second from RPM. If they give you RPS, radian per second, then no 60. If they give you RPH, then 60 times 60. Because in 1 hour, 60 minutes, 60 seconds. This is just a pre-explanation of what we are going to study now. Relate the magnitude of linear and angular velocities for circular motion as v is equals to r omega and explain that this relation does not hold for tangential and angular velocity. Which point in different directions? Explain that this relation does not hold for tangential and angular velocity vectors. We are not talking about directions here. Which point in different directions? Okay. Solve problems related to angular velocity, angular frequency and period. Okay. Remember, whenever we are saying that v is equals to r omega, we are not equating them vectorially. We are just equating them numerically. That means the number wise. Because omega and v has completely different directions. The actual relation for v is equals to r omega is v is equals to omega cross r. This is the relation. But you don't have to go in that detail. It's not even there in your curriculum. So v is equals to r omega, we'll keep it just numbers. Numerically they are equal. In a department store toy display, a small disc of radius 0.100 meter is driven by a motor and turns a larger disc, disc 2 of a radius 0.500 meter. Disc 2 in turn drives disc 3 whose radius is 1 meter. The three discs are in contact and there is no slipping. No slipping, that means they are not sliding over each other. Disc 3 is observed to sweep through one complete revolution every 30 seconds. They have given you the picture. So the time period for this one is 30 seconds. Every 30 seconds it can sweep across. But this is the one which is rotating. Because of this one is rotating, and because of this one is rotating. That's the rotation. They are continuously going. So linear speed at this point and the linear speed at this point will be same. Remember, linear speed, v will be same. But omegas will be different. This will do multiple times full rotation to make this thing completely rotate once. And this will do multiple times full rotation to make this thing continuously move at complete one rotation. This is how basically gears work in your car. So what are they asking? What is the angular speed of disc 3? Angular speed of disc 3. I know the time, 30 seconds. In 30 seconds, how much angle it is tracing? 2 pi. So the angular speed is given by theta. That means how much angle it has traced over time. So that is 2 pi over 30. Whatever the value comes, 2 pi over 30, 0.209 radian per second. The second part, what is the ratio of the tangential velocities of the rims? Tangential velocities or linear velocity, same thing. What is the ratio of the tangential velocities of the rims? So rims, this point, all are moving with the same linear speed. So there will be, the ratio will be 1:1:1. That means, and how much will be the velocity? So if I have the omega, I can find the linear velocity for this one. That will be v is equals to r omega. R for this is r3 or whatever the value is, 1 meter times omega is 2 pi by 30. I put the value, you'll get 0.209 meter per second. And this same velocity will be for this point also, and for this point also. Like whatever the points are in contact. So because the rim speed, if it is continuously moving at the same speed, rim means this. So this one is in touch with this one, so the speed will be same. This one is in touch with this one, so the speed will be same there also. What is the angular speed of the discs 1 and 2? Angular speed. We don't have to find out the linear speed, angular speed. That will be different. So to find out the angular speed, we need to check that how much time this one takes to complete the full rotation here. Okay? They have given you, okay, they have not given you the time, but that's fine. If I have the linear speed, I know the linear speed is same for all three. So for this one, omega will be V over R2, whatever is the velocity over radius, and velocity we have calculated in the previous part, 0.209 over radius is 0.5. So you will get the angular speed, and you can see that the angular speed here and the angular speed here are double, kind of. Why they are double? Because this one would be rotating faster over this one. It would have to cover at least 2-3 circles to make this one rotate at least once, and this would have to cover multiple ones. So this one's angular speed is going to be faster, 2.09. Same thing, speed over radius. If the motor malfunctions, that means it goes bad, resulting in an angular acceleration of 0.100 radian per second square for disk 1, what are disk 2 and 3's angular acceleration? Again, linear acceleration will be same, angular acceleration will be different. Because linear acceleration, because they are attached to each other. So I have the resulting in an angular acceleration of 0.100 radian per second square for disk 1. First I will find the linear acceleration, A, which is alpha by r. And this alpha by r, that means 0.100 over r. R is whatever is the radius, 0.100. So this comes out to be 0.100 over 0.100, 1 meter per second square. Is there centimeter? 0.100 over 0.100. Yeah, this comes out to be 1 meter per second square. This is alpha. Sorry, this is A, acceleration. Why have they put here 1 into 10 to the power minus 2? Is it centimeter or meter? This would come out to be as 1. There won't be any 10 to the power minus 2 because it's no centimeters here. It's all meters. Everything is in like meters, so you don't have to put the 10 to the power minus 2. I think that's a small mistake. Anyways, that is the A. Now A for all the other discs will also be same. So if I need to find out alpha for the second disc, that will be A by R2, and alpha for the third disc, that will be A by R3. When they are attached, their linear speeds, linear accelerations are same. A discus thrower with an arm length starts from rest and begins to rotate anti-clockwise. A discus thrower with an arm length of 1.2 meter. A discus thrower is basically who goes like this. So here is the arm length of 1.2 meter, starts from rest and begins to rotate counterclockwise, anti-clockwise, with an angular acceleration of 2.5 radian per second square. So I have the angular acceleration alpha, and I have the radius, you can say that 1.2 meter. How long does it take the discus thrower's speed to get to 4.7 radian per second? We need to get there. We have 3 equations of motion which we studied there before. You can also apply the similar equations for angular speeds or circular motion. Omega final is equals to omega initial plus alpha t. Delta theta is equals to omega initial time plus half alpha t square. And omega final square is equals to omega initial square plus 2 alpha delta theta. These are the relations. You already have R, radius, From here, you can find out, this is alpha, which is given. Omega initial, he starts from rest. So omega initial is 0. Okay, what are they asking? Take the discus thrower to get to a speed of 4.7. 4.7. So this is omega final. What is the time? So omega final is equals to omega initial plus alpha t. This is 4.7 equal omega initial is 0, alpha is 2.5 times t. T will come out to be 4.7 over 2.5, that is 1.88 seconds. What is the linear speed? If I have the omega, then I can find out the linear speed, which is v is equals to r times of omega. Just multiply it with the radius, that is the length of the arm. What is the linear acceleration of the discus thrower at this point? At what point? Linear acceleration. If I have the angular acceleration, linear acceleration, because it's constant, so a is equals to alpha by r. A is equals to r alpha. Alpha is equals to a by r. So r times of alpha, I have the radius, I have the alpha, I can simply multiply. What is the magnitude of the centripetal acceleration of the discus thrower? Centripetal acceleration, if something is rotating or moving in a circle, there is always an acceleration pointing towards the center, which keeps it moving, and that is called centripetal acceleration, v square by r. I have the velocity. Do I have the velocity? Yes. I have the velocity 5.64 over r 1.2. You can find out the value. What is the magnitude of the discus's total acceleration? Here is the point. If something is moving in a circle and it is speeding up or speeding down, there are two accelerations. One is centripetal acceleration and one is the tangential acceleration, which is making it move. So whenever we have to find out the result, we find out a net. That is root ac square plus at square, because they are at 90 degrees with each other. The a which we find out from here, from the angular acceleration alpha, that is the tangential acceleration also. Remember, linear acceleration or tangential acceleration. Here it's the same. So I have the at, I have the ac, I can find out the value, whatever the result comes. And will the a net point out towards the center? No, it will point out somewhere in between. A particle is moving clockwise in a circle of radius 1 meter. At a certain instant, the magnitude of its acceleration is 25 meter per second square. Okay. And the acceleration vector has an angle of theta is equals to 50 degrees. That means it is a net with the position vector as shown in the figure. At this instant, find the speed, magnitude of the speed of this particle. So it's simple. You have like this, and at certain instant has an angle of theta is equals to 50 degrees with the position vector as shown in the figure. So this is the position vector here, and this is the net acceleration. This angle is 50 degrees. So this is the velocity somewhere. Now if it is rotating in this direction, then at this point, this side there will be AC and this side it will be AC. This I already know. How much? Acceleration is 25 meter per second square. So this will be 25 cos 50 and this will be 25 sin 50. And get the acceleration. What do they want? As shown in the figure, at this instant, find the speed v of this particle. I need to find out the speed of the particle at that particular instant. So centripetal acceleration AC will come out to be 25 cos 50. Centripetal acceleration is equal to v square by r. If I have this value, I have the radius, I can find out what is v. Simple. All you have to do is find out the value of v. By that, all you have to do it basically, for that, all you have to do is find out the centripetal acceleration. Components you should know. The component which is with the angle is always cosine. So a cosine 50 and the other one is a sine 50. Gear A with a mass of 1 kilo and a radius of 55 centimeter is in contact with gear B with a mass of 0.500 kilos and radius 30 centimeter. The gears do not slip with respect to each other. Okay, do not slip. That means the linear speeds are going to be same. B will be same. Gear A rotates at 120 rpm. So 120 rpm. It slows to 60 rpm. From here it gets to 60 rpm. Okay. Omega initial, not omega, but basically initial, and this is final. 120 times 2 pi by 60 will give me the omega. So that's rpm. How many rotations does gear B undergo during this time interval? Okay, so in 3 seconds, basically, how many rotations does gear B go through? That we have to find out. Okay. Again, step by step. First, converted RPM to omegas. This is omega initial, this is omega final. Then find out the angular acceleration. Alpha is equals to delta omega by t. I have the time, I have the change in angle. Alpha comes out to be minus 2 pi by 3. Then, because you know alpha for this, you need to find out alpha for this. You want to know that how many rotations does it go. So you need to find out alpha for this. But accelerations will be same. AA will be same as AB. Acceleration, because linears will be same. So acceleration is A is equals to R alpha. So R A alpha A should be equal to R B alpha B. I know the radius for both the things, and I know alpha A. I can find out alpha B, whatever is the value. You get alpha B is equals to minus 11 by 9. Once you get alpha B, you have to find out like what is initial omega B. Because velocities are same again. So omega is equals to V by R. So initial omega B and final omega B. Omega initial, omega final. Because you have omegas for the A but not for the B. And now you have acceleration alpha B basically. So you can find out omega initial and omega, because what's happening is because velocities will be same. So VA will be equal to VB. If VA is equals to VB, then I can say that RA omega A will be equal to RB omega B. So omega B will come out to be RA by RB times omega A. RA by RB times omega A. So if I have to find out omega B initial, I will use omega A initial. If I have to find out omega B final, I can use again, if I have omega A final, from here I can find out RA by RB, you will get the result, whatever the value. So you can do it that way also, it will give you the same result. Here they have used the acceleration, that as well can be done or could be used. Basically what you are using is omega final is equals to omega initial plus alpha t. You have the time, you have calculated the acceleration, omega initial is what you have calculated in the previous step. Once you have that, now you have the omega final for B, you have the omega initial for B, you have the time also for B. All for B. And now you have to find out how many rotations does it make during this particular time period. So I have a relation. If you can find out the angle, we don't even need the time. Omega final square is equals to omega initial square plus 2 alpha delta theta. All for B. This is B, this is B, this is also B. I will get the angle. Once I get the angle, if I divide it by 2 pi, I will get the number of rotations. Here they have taken average and all that. I would recommend don't do that. I mean, if you are not familiar with that, rather use the equation of motion, and from here you will get the number of rotations. Why am I dividing it with 2 pi? Because in one rotation the angle is 2 pi. Relate the magnitude of the centripetal force to the centripetal acceleration. We have discussed this in class multiple times. I have told you as well. Like we did an experiment as well in which I was rotating an object with the spring attached to it. The force is continuously pulling it towards this. This is the centripetal force, and this centripetal force is mass times centripetal acceleration. Centripetal acceleration is v square by So a vinyl record plays at 33.3 RPM. From here you can find out omega. Whatever is the value, 33.3 times 2 pi by 60. Assume it takes 5 seconds for it to reach this full speed. This is the time. If it starts from 0 and it is reaching at the full speed. So omega initial is 0, omega final is this. What is its angular acceleration during the 5 seconds? You can calculate alpha is equals to omega final minus omega initial over time. You have the time. Omega final is not this, remember. 33.3 times 2 pi by 60 minus 0 over 5. Solve it, you will get the result. How many revolutions? Okay, I'm going very fast. You can always slow down whenever you feel like, and then you can go through it. Okay. How many revolutions does the record? Because you have the option to basically go 0.5x, 0.7x. I will be able to finish it faster. How many revolutions does the record make before reaching the final angular speed? How many revolutions does the record make? In one revolution, it takes 2 pi angle. So first, we need to find out what is the angle trace. So delta theta is equals to omega initial t plus half alpha t square. I can use this. I can use the previous one also because I have the omega final, omega initial. So omega final square is equals to omega initial square plus 2 alpha delta theta. Once I get the delta theta, that is the displacement, I can divide that delta theta by 2 pi and I will get the number of rotations or number of revs. How many revolutions did it make? The solution is given, it must be some different form. You can go through it. Suppose a vertical loop has a radius of 5 meters. What does the linear speed of the roller coaster have to be at the top of the loop for the passenger to feel weightless? We don't feel gravity. We feel the push of the ground on us. So there is a force which is its weight mg, and because there is an mg and the ground is at rest, it pushes it back, like pushes us back. That is the normal reaction. That is what we feel. If the ground underneath also starts moving with the same speed as we are, therefore the ground will not be able to push us. So we will not be feeling any weight. If we feel complete weightlessness, if normal is 0, that means the reaction force becomes 0. Okay. For anything to move in a circle, there has to be a force towards the center. This force will be provided by some force which is already present there. It could be friction, it could be normal reaction, it could be gravity, it could be tension, it could be spring force, anything. Now, they are saying that suppose the vertical loop has a radius of 5 meters, what does the linear speed of the roller coaster have to be at the top of the loop for the passenger to feel weightless? At this point, they want the passenger to feel weightless. What are the forces acting at this point? So here, there is a force which is weight, that is mg. And if I am in the loop, then this particular surface which is holding me there, like here at this point, I will also feel a normal reaction downwards, but I want my normal reaction to be 0. I don't want any normal reaction on myself because I want to feel completely weightlessness. So I can see that gravity or weight is the only force which will be able to provide it the centripetal force. Remember, centripetal force is provided by an already existing force. So mg must be equal to mv square by r. M will get cancelled, v comes out to be root rg. Be the speed at this particular point where mg itself will be able to balance or provide the centripetal force and we will feel 0 weight. So it is root gr. The maximum, here at this point what happens, mg is downward. So there must be a force which is taking it up and therefore normal comes in. And normal must push towards the center. So normal should be more than mg. Only then the object will be able to go in the circle. That's very, very important. That remember, if something is moving in a circle, there has to be a force which is acting towards the center. If it is not there, the object cannot move in the circle. Let's take this here. We have a race car which is a race car is making a U-turn at constant speed. The coefficient of friction between the tires and the tracks is mu is equals to 1.20. Now see, if it is turning, there is nothing, no force which can provide, which can be applied towards the center. And if there is no force, what can be there? Friction. I need friction. Because if there would not be any friction, it would not be able to be held into the circuit, into the circle. It will drift apart. So this force is the frictional force. And how much is the frictional force? Frictional force is given by mu times of normal, if you remember. And here, if it's a flat track, then mg is downward, normal will be upward. So mg will be equal to normal. So mu is mg. This is the frictional force. And this frictional force must provide the centripetal force. Mu s mg must provide mv square by r. And if that happens, m gets cancelled, b comes out to be root mu s rg. This is the speed which we have to find out. Assume that the car is undergoing uniform circular motion. What is the maximum speed? This is the maximum speed it can handle. You must have seen at some points, at some times what happens, when you are turning, the roads are tilted at an angle. The reason for the roads to be tilted at an angle so that some part of the gravity can also provide the centripetal force. Because now this component, a little bit of this will be here, it will be able to keep the object in the circle. So banking, this is called banking of the road. Banking is done to provide, like to have an extra support for the centripetal force by gravity. And there is friction also, so gravity and friction combined will be able to give me relatively more force towards the centripetal force, and therefore I can go on higher speeds. That is why the turns which are at 120-160 kilometers per hour or the racing tracks, the roads are slightly banked. They are at an angle, they are tilted. A car speeds over the top of a hill if the radius of curvature of the hill at the top is 9 meters. If the radius of the curvature of the hill at the top is 9 meters, how fast can the car be traveling and maintain constant contact with the ground? This is the car. The only force which can provide it the centripetal force is mg. And if it is mg, then mg has to provide the centripetal force. It is mv square by r. M will get cancelled, b comes out to be root rg. Put the value, whatever is the result, they have given you the radius and all that. Okay. A ball having a mass of 1 kilo is attached to a string 1 meter long. Whirled in a vertical circle at a constant speed of 10 meters per second. Basically, I have a string and I have been rotating it. We did this experiment in the class as well with the open water bottle. Determine the tension in the string when the ball is at the top of the circle. Tension, because tension is the force which is keeping it together. But at different points it changes. Why does it change? So think of it like this. At this point, at the lowermost point, what is happening? Mg is acting downwards. Therefore, tension has to act in this direction and it should be more than mg. Only then there will be a force towards the center to provide centripetal force. But at this point, mg is acting downward. So tension is also acting downward there. Not so, but tension is also acting downward. So here mg is supporting the tension. But here mg is opposing the tension. So at this point, tension will be more because tension would have to be more. Imagine mg is 10 newtons. Let's talk numbers. 10 newtons. This will be 10 newton here also. To keep this in the circle, let's say the force requirement is 40 newtons. Let's assume. This is the centripetal force required to keep this in the circle. Now, if mg is 10 newton in the opposite direction, tension would have to be 50 newton. So that 50 minus 10 comes out to be as 40, and 40 newton basically acts towards the center so that it can move in the circle. But at the topmost point, what is happening? Tension and mg, they both are in the same direction. Now mg is 10, tension only has to work 30 newton to get to the required 40 newton mark. So at the topmost point, tension would be lower, at the lowermost point, tension would be higher. Okay. here I can say that basically the net force required is mv square by r, and determine the tension in the string when the ball is at the top of the circle. So at the top of the circle, I need tension minus mg, or basically what we are doing is at the top of the string, tension plus mg is providing me the mv square by r. So tension comes out to be mv square by r minus mg. But at the lowermost point, tension has to be more. That means tension minus mg will provide the mv square by r. Tension will come out to be mv square by r plus mg. This is the tension, mv square by r plus mg, and here the tension is mv square by r minus mg. Consider the ball at some point on the other than the top or the bottom. If we take a point anywhere in general, there is mg downwards, there is tension here. So some part of the tension will cancel mg, or tension will provide the centripetal force. And if I take the component, this is mg, let's say this is theta, so this becomes mg cos theta, and this becomes mg sin theta. This becomes mg cos theta, and this becomes mg sin theta. You don't have to solve it again. Here tension would have to cancel mg cos theta. Tension minus mg cos theta will provide mv square by r. So it will be slightly lesser than here, but here it will be like, what's happening is here tension is maximum. Then it starts reducing. At this point it's minimum. And then it starts increasing again and then comes back here. So this rope is in maximum stretch at this point. And it is in the minimum stretch at this point. Actually, it's a very interesting question. Like, what should be the minimum speed for the vertical circle? You should know these values. The minimum speed for it to remain in the circle at this point is called root 5 gr. And at this point it is root gr. You don't have to remember it, but you should know this. Because here I require less tension and at the bottom I require more. A vinyl record that is initially turning at 33 rpm slows uniformly to stop in time of 15 seconds. So I have omega final is 0, omega initial is 33 rpm, which you can change. How many rotations are made by the record? First find out the angular displacement delta theta using the equations. Once you have that, divided with 2 pi, you will have the number of rotations. A car accelerates uniformly from rest and reaches a speed of 22 meters per second in 9 seconds. Okay, I have the final speed, I have the time. Starts from rest, initial speed is 0. The diameter of a tire of this car is 58 centimeters. So I have R. Find the number of revolutions the tire makes during the car's motion, assuming that no slipping occurs. So it's all rotation. Okay. What is the final angular speed of the tire in revs per second? We have to find out. Okay, let's try this. You have to basically convert the linear and the rotational part of here, like circular part. Uniformly from rest and reaches a speed of 22 meters. So V initial is 0, V final is 22, time is 9 seconds. The diameter of a tire on this car is 58 centimeters. Find the number of revolutions on the car during this set. So when it is 22 meters per second, I can find omega final, which is RV final, because omega is equals to V by R, sorry, my mistake. Omega is equals to V by R. So I will get V final by R final. I get omega final. If it is moving at 22 meters per second in 9 seconds, find the number of revolutions the tire makes during the car's motion, assuming that no slipping occurs. So if I have to find out the total distance, I don't need the distance here. What they have done, 2 pi r, that is fine. The displacement is constant, v is equals to r omega. So delta x A comes out to be half delta V delta T. Let n is equals to number of revolution. The displacement given by this per revolution is simply the circumference C. Okay, that is one way of doing it. What they have done is, like, in one rotation, basically, how much distance it is covering. So start from this and it goes all the way around. So how much distance it will cover? This is R. This will cover this much distance, which is 2 pi r. If I calculate the distance the car has traveled in 9 seconds, which can be again calculated by displacement is equals to V initial t plus half at square. Or you can use V final square is equals to V initial square plus 2 alpha. Do we know the A? No, we don't know the A. So I can use V final is equals to V initial plus at. V final is 22. V initial is 0. A I don't know times 9. A comes out to be 22 by 9. Once I have A, I can put it in any value. You will get the displacement here. Displacement. So you will get the displacement. Once you have the displacement, V initial t plus half alpha t square, like half at square again. This displacement is the total displacement car has covered. If you divide that by 2 pi r, you will get the total number of rotations or the revolutions which the car has made. That's one way of doing it. Another way of doing it is you can find alpha. So I have omega final, omega initial is 0. So I can find alpha, which is omega final over omega initial. I can find alpha, which is omega final minus omega initial over time. I have the time. Once I get alpha, now I can find out delta theta. Because omega final square equal omega initial square plus 2 alpha delta theta. Once I have delta theta, I can divide it with 2 pi, I will get the number of revolution. But actually, I think their method is relatively easier. So what they have done is that in one rotation, in one rolling completely, I travel a distance of 2 pi r. I have the radius of the wheel, so this is 2 pi r. If I calculate the distance which the car has traveled in 9 seconds, is given by V final is equals to V initial plus at. From here find A, and then you have displacement is equals to V initial t plus half at square. Term 1, equations of motion. Put the value of A, you will get the displacement. If I have the total displacement as 40 meters, and in one rotation the car travels a distance of 2 meters, so how many rotations it would take? 40 divided by 2. So whatever is the distance, divide 2 pi r, get the number of revolutions. That's what they want. We can find it out. Displacement over revolution will give you the number. Okay. The second part, what is the final angular speed? So we have omega is equals to V by R. R is distance. We find out whatever the value is they have given. So that's what we were doing in the first part before, by finding omega and all that, and then you can solve it. Calculate the moment of inertia of point, particle or group of several points. So moment of inertia is basically, you can say that rotational mass, that is called moment of inertia. So if moment of inertia is given by I is equals to sigma mi ri square. So if I have, let's say this is the axis of rotation, and I have 4 masses, or any masses, let's say 1, 2, 3, 4, 5, 6. 1 kilo, 2 kilo, 3, 4, 5, 6 kgs. Radiuses are different, radii are different. This is 1 meter away, this is 4 meters away, this is 7 meters away, this is. So all you have to do is mass times the axis, the perpendicular distance from the axis of rotation, square, and then keep adding them like that, and then eventually you will get the total moment of inertia. For discrete, that means non-continuous particles. So before going to this question, let's do a small simple question where you have to find out the moment of inertia. There is a mass 2 kilos, 1 meter apart, and there is another mass 3 meters apart, 5 kilos. And you have to find out it is a system, they are combined together and it is rotating. You need to find out the moment of inertia of the system. So it is given by m, that is 2 times 1 square plus 5 times 3 square. This comes out to be 2 plus 47 kilogram meter square. This is the moment of inertia. Now, when it is a continuous body, then it gets into integration. So if it's a continuous body, it goes as integration dmr square. Then you have to solve it and all that, but you don't have to remember all that. You have to remember some moment of inertia. For example, for a ring, and remember, when the axis changes, the moment of inertia changes. If it's a ring and it's rotating around the center, the moment of inertia is mr square. If it's a ring or it is a hollow cylinder, the result is same. Hollow cylinder like this. If it's a disc, like this, the moment of inertia is mr square by 2. And if it's a solid cylinder, then also it is mr square by 2. These are important, and there is one sphere. If it's solid sphere, filled inside, 2 by 5 mr square. If it's hollow sphere, 2 by 3 mr square. Where do we need it? Why do we need it? And all that. It's all comparisons basically. Everything is exactly the same whatever we had it in linear. For example, in linear and angular. In linear we have displacement, here we have angular displacement. Delta x, delta theta. In linear we had velocity, here we have angular velocity. In linear we have acceleration, here we have angular acceleration. In linear we have force, here we have torque. In another sense, basically torque. In linear we have mass, here we have moment of inertia. In linear, let's say if the kinetic energy is half mv square, all the expressions can be used here. Rotational kinetic energy will become half. Instead of m, I will use I, omega square. Instead of v, I will use omega. So all the results can be interchangeably used, and there is a correlation between them. A uniform solid cylinder of mass m is equals to 5 kilos. Yeah, sorry. So what I was saying is that they are completely interchangeable, and there is a correlation between them as well. Now, a uniform solid cylinder of mass m is equals to 5 kilos is rolling without slipping. Whenever there is a term called rolling, when we say rolling, it's basically moving. So this system is moving translationally, that means it is moving forward, as well as there is an element of rotation. So it is rotation plus translation. Translation means forward movement and rotation is the movement along the axis. So rolling without slipping along a horizontal surface. The velocity is center of mass is 30 meter per second. So the center of mass is moving at the speed of 30 meter per second. Calculate its energy. When we say calculate its energy, we mean rolling energy, that means rotation energy, and translational energy. So total kinetic energy in rolling is given by rotational kinetic energy plus translational kinetic energy. Translation kinetic energy I know, half mv square. Rotational kinetic energy is half I omega square. Now, if it's a solid cylinder, I have I, which is mr square by 2. This is half. Omega. If I know the velocity of the center of mass, basically it is moving with the r omega. So omega comes out to be v square by r square. Because omega is v by r. Plus half, I have the mass, I have the velocity. Just put these values. This is the total kinetic energy. You don't have to remember any formula or anything like that. All you have to do is half I omega square, the rotational kinetic energy, and the translational kinetic energy. Determine the moment of inertia of 3 children weighing 60 kilos, 45 kilos and 80 kilos sitting at different points on the edge of a rotating merry-go-round which has a radius of 12 meters. Okay. Since all children are on the edge, basically they all are at the edge of a merry-go-round, like something like this, which is, you can imagine this. One is sitting here, one is sitting here, one is sitting here. This is rotating around this. This is 60 kilos, this is 45 kilos, and this is 80 kilos. At different points on the edge of a rotating merry-go-round, and this is rotating continuous, which has a radius of 12 meters. So this is the radius, 12 meters. Since all children are on the edge, okay, now we need to find out the moment of inertia. So everybody is tracing a circle of 12 meters. Perpendicular distance from the axis of rotation is 12 meters. So it will be m1 r1 square plus m2 r2 square plus m3 r3 square. This is the moment of inertia. So 60 times 12 square plus 80 times 12 square plus 45 times 12 square. You can take any as m1, m2 and m3. Put the values, whatever the result comes, this much kilogram meter square. This is the moment of inertia. And these are all the writing questions. In the next part, we'll do the multiple choice.